Happy Thursday, everybody. Welcome to our Recon Office Hours. We're gonna get started. As I anticipated, the first thing we'll do is I'll show you how to build a couple of Codarina repos. We are seeing a lot of people trying to build the Ondo Finance repo. So I'll just show how I debug it, because most likely there's a bug. And basically, we'll just show you how to build that. And then for people participating in the arena this week, we'll also build a Panoptic repo so that you get an advantage there. And I'm gonna start by sharing my screen. After that, I'll talk about some learnings from the Optimism Contest. I'm not gonna leak any vulnerability, so it's not gonna be anything crazy, but it's gonna be something to make you think. Let me know when you see my screen, please. Anybody on mute? Say yes or no.
Yes, I can see it.
Amazing. So this is a new, very small thing I wanted to show. We track the amount of repos that have been built with the tool, and we're basically having some sort of a tracker here. So in terms of the two repos that we were having issues with, one of them was the Ondo Finance. So I'm just gonna go on Codarina. I'll do my best to find it. Audit page, there we go. And we've seen like 10 plus attempts at this, so most likely there's a bug. So the first thing I'm doing as I open up the Ondo Finance repo is I'm trying to determine whether this is a Foundry repo. The easiest way would be to just search for Foundry. And then the second thing I'm trying to do is determine what the out is. The out is called Artifacts Forge. And so just out of safety, this is my advice typically, will be to just clone the repo. Good old git clone. And I'm just gonna open it and I'm gonna compile it locally to see if there's anything weird. And so the way our builder works is it works out of the box with any open source Foundry repo. So all I'm gonna do is I'm gonna try and forge build and see if that's sufficient. And it seems like it is. You see 168 files. So I'm gonna take a guess, and maybe we'll see whether we, because we have a couple of bugs here where once a unsuccessful build happened, you may end up getting an empty project. But as far as I can tell, this is gonna work. And the only weird thing that is gonna happen is that it's gonna produce the output folder in this Artifacts Forge repo. So I guess we'll check it. You can see here Artifacts Forge, we got our good old ABI. So as far as I can tell, that's all we gotta do. So I'm gonna open Foundry, grab the URL. I'm gonna go on Recon. And to build a repo, you just go on the public repo folder. You, because of the custom folder here, we're gonna go on the last option and paste it. And then the only thing you gotta do here is just copy this and you paste it up here. And so this is our organization, this is our repo, this is our branch. We compiled from root, so you don't have to set any directory. So we're gonna just start the job, see what happens there. See if I can see it. There you go, ABI being built. So there's a possibility that this will fail. Maybe we'll investigate it a little bit, but as far as I can tell, that's gonna be all we're gonna need to do. And then you just have to give it a few minutes for it to be done. So that's gonna be it. And I would expect, I guess, let me refresh. We see that something updated, so I'm gonna just refresh the page just in case. Seems like the job actually disappeared. Let's try one last time. And maybe, I guess we do have a bug on this repo. Okay, I guess we do have a bug on this one, so we'll investigate. Let's try and build the Panoptic repo instead. And I'll follow up on this repo very soon. So I'm gonna go and find the Panoptic contest. In this case, we still have Foundry, so we should have the foundry.toml file. And the out is the default out, so we actually would expect 0 issues. With this one, we see the package.json, but we don't see any npm package here, so we don't expect any particular requirement. I'm just gonna paste the URL. The default branch is main, so that's gonna be it. And that should be about it for Panoptic. We see that somebody else already built it, by the way. And so that's why it loaded that fast. And so if we open up all of the files, we are able to access these different contracts, and you can then scaffold the properties. A couple of nice things we fixed, a couple of bugs we fixed on the builder. We now build all of the test folder by default by using Foundry compile all. So you should no longer have issues with compilation if you use Medusa. And there was a tweet by Rappi about this configuration, but we went through it and this is already compatible with Medusa 0.1.3. So you should have no problems getting started with Panoptic. And so as I wrap up this first example, obviously we'll do an announcement once we fix the Ondo repo. Something that, first of all, if you want to unmute if you have questions. Otherwise, something I want to mention is that in security research, you almost want to have kind of two heads and two faces. One face is about learning about the system. And so with Panoptic, you will want to learn about delta neutral options, UniV-free math, ticks, how the non-fungible position manager works, etc. So there's a lot, to go in depth there. And then on the other end, you just want to have a period where you just grind out the code basically just to make it, compile or make it do whatever you're trying to do. Yeah, you want to ask a question? Feel free to unmute if you want to ask a quick question. And okay, I guess I'll just keep going. So that was the setup. Any of you can just grab this URL, and because we already built it once, everybody will have access to the same API data. So you don't even have to wait. You can go fuzz Panoptic as soon as possible. And obviously, if you don't know anything, you can go back to the dashboard page and just check a couple of tutorials. We have an hour workshop, 50-minute workshop. So the tutorial on the platform are there. I guess I'll introduce our Recon bounty at this point. So if you're going to participate in a public contest or you're going to do a public audit, and this needs to be a public report, so don't send us private information, don't leak sensitive information, only send us public reports. But if you end up making a valid submission to a contest or a bug bounty or a audit by using Medusa and using the Recon scaffolding, so basically you use the handlers I showed you and you find a bug with it, and this is part of your POC, send it to us, and then every month in the last Thursday of the month, we do a office hours every Thursday. So the last Thursday, the last office hours of each month, we'll collect the best submissions and we're gonna award the best one with 150 USDC, and we'll also shout you out for your work. That way we're building a collection of trophies for Medusa. We can send them to the public repo for Medusa as well. And then at the same time, you're promoting a little bit of the technology that we're building. So from our point of view, you are promoting our work. And then from the point of view for, I guess, for your advantage, you are writing coded POCs that are going to help you. That's something that we aim to achieve a bit longer term. As of today, what we got is just this scraper. But our plan, basically this scraper allows you, when you paste the Medusa logs, to generate your Foundry tests. But long term, we want to also have a visual way to represent your POC. So that way you just set up Medusa, you find bugs, and then you basically have a POC built and explained without having to spend a lot of time on that. So that's kind of it for the first part of our presentation. The second part is going to be tied to the work I did on the Optimism Contest. As I said, I'm not gonna send you my vulnerabilities, obviously, but funnily enough, the contest, and I don't know if any of you paid attention to that, but Optimism announced that their fault proofs were live on Sepolia a week before the contest. So if you had any awareness, you actually could have had access to the code a week before if you went and checked. As far as I know, this is basically the same code. There is no difference in versions. Maybe there's slight differences, but I'm not fully aware. And so something that I want to talk about was something that I tried that didn't work. So I'm very comfortable in talking about it because there's no vulnerability there. But it's something that can help you long term. And so I guess, what is the weirdest thing that you can see when you look at this code? Anybody want to take a guess? What strikes you as a Solidity warrior? What is the odd one out of these imports? Anybody willing to take a guess? No named import, blah, blah, blah. No, it's Soledi. It's going to be, yeah, maybe you were going to say it, but it's going to be Soledi, which, if you're familiar with the most common library ever as a security researcher, is going to be OpenZeppelin. The spicier version of OpenZeppelin is Soulmate, and then the spiciest version of Soulmate will be Soledi. And so it is actually a remarkable act of confidence to use the optimized version instead of the reference version. And that's something that I've spoken about in the past, and it's the idea of, and I totally stole the idea from Seaport, by the way. If you've never checked Seaport codebase, you should go check it out. But basically they have a reference version, which is easy to read, simple to understand. And then they have an optimized version, which is full assembly, full send, save every byte type deal. And what you do is you do differential fuzzing on the reference version against the optimized version. And so it actually, something that I explored was related to the bond price. I don't remember, the get required bond. So this function get required bond, and again, as far as I'm aware, what I'm going to show is completely innocent, so I wasn't able to find any high impact, but I just want to show you the level of forwardness that you can go through on something so basic such as a view function for pricing a bond. And so the first thing I did was I just look at this and basically try to understand it. It fundamentally tries to price a certain amount of gas between 400K and 200 million. And then even if you zone out here, like even if you don't fully understand this, they're basically pricing it on exponential curve. And so they're using fixed point math, which again is from Soledi, not from Soulmate, to perform that. And so the first idea that I had was to go and check whether a implementation written in Soledi versus Soulmate will be different, simply because most of the times optimized code either breaks at a certain bound, or it potentially has some slight difference that could be found very quickly via the fuzzer. And so that's exactly what I did. I went and created my own little private repo, and I basically scraped out uh, the Soulmate version and the Soledi version. And funnily enough, I had to import multiple Soulmate files because a couple of them were separate. But ultimately, I simply took both libraries. I created a map between the Soledi version and the Soulmate version because they have different names. And then I created a couple of these Soulmate and Soledi user, which are basically just these very basic functions, right? Super simple. You just call the library. And the reason why I made them external, in this case they were public, but fundamentally they were external so that I could do a try catch so that I will be able to capture whether one of them reverted versus the other and whether the value that they were returning was the same. And so this is a very simple idea, and this is actually kind of a toy scenario. It's almost professional. It's like the simplest professional example you can find is basically fuzzing 4 functions each and just seeing how it goes. But this is such a profound idea, to me at least, because anytime you don't want to deal with the code, like you don't want to read the shifts, the bit shifts, the whatever algorithm that they wrote, you can just find a way to find a proxy for finding a vulnerability. And so that's something that you want to have in your toolkit, is that sometimes you have to understand the code. Like an example will be reading the bond math and the prices. And I'm not going to talk about that too much, but something that I did was I literally charted out the function. So that's something that you can do to learn it better. But when it comes to instead checking whether it would have behaved differently on an optimized versus reference version, you can look at this entire function as a black box that you don't look into. You just have that inputs. And then instead of fuzzing a fault dispute game version with Soulmate versus one with Soledi, I just took the 4 functions that were key to the behavior, and I just fuzzed them separately so that it was even easier to do, and it was easier to debug, because obviously what can revert here. And funnily enough, something that actually did revert was the something I'm not super familiar with, but basically this Soulmate down file was actually not a library. It was literally just or maybe it was the Soulmate file, but basically one of them was not even set as a library. It was just set with these floating functions. And so anytime I would call them after importing them, I would actually get a stuck too deep error. And so initially I actually thought I was going to get, some an actual bug. And then once I refactored it to being a library, I realized that it was always reverting because of for whatever reason. So that's an example of something that can help you find bugs by proxy, right? Because something to consider is the fact that had I found a different behavior here, that wouldn't have necessarily meant that I was going to find a bug that applied to this function. Simply because the domain here is every possible integer or every possible signed integer, whereas the domain here is going to be a value that is an acceptable position. So, which by the way, you can scrape from the chain. So this corresponds to 73. So that's another aspect to keep in mind, is that finding a bug through the fuzzer, it's literally finding a proxy for a possible vulnerability. But at the same time, it's something worth exploring, especially when you're completely overwhelmed by the math or the logic, because you can always do something. Like, or maybe like if this math is really basic to you, you can just read it or whatever. But if it's not, you can always still try something where you can treat the entire formula as something that just gives you back some input. And so you can try to break it in that way simply by trying to interact with it. Hopefully that inspires you a little bit. There's more things that I can talk about, but I'll talk about them when findings are made public. But something that I can say is that even just to I guess visualize this formula, something that I've done is I basically created my CSV generator, and it sounds a lot more complicated than it is. It's just a way to log stuff from Foundry. But something that you over time want to do is you want to have kind of your process when you understand something fully. Obviously, you just break it in your head, you're done. When you need to visualize it, you want to know that, and so you build ways to visualize fast. An example was actually in the explanations of the fault dispute games by Clabby. He built his own visualization tool. I don't know if you guys paid attention to that, but there was an entire visualization of the game that could be helpful. And so that's basically the same idea. Is if I need to look at a formula, I can actually look at a formula by printing out a chart that is going to help me reason around it. And then another aspect is you want to look at differences of the formula based on implementation and a proxy for that, because obviously I could have rewritten everything in Python, which I did, or rewrite everything in Soulmate versus OpenZeppelin versus Soledi, and then compare them. But something that you can do when you understand the proxy aspect is you just take the minimal idea, which is basically just the division function, logarithm function, exponential functions, and you compare those. And those are these broken tests potentially. In my case, I didn't find anything, but these broken tests, they can potentially be proxies for inputs that can then cause issues in the broader system. And so you don't necessarily need to use the fuzzer to find you the entire sequence of attack or the entire exploit. You can just use it to give you a pointer or give you a specific state that helps you get to the next level or helps you get to a new point. And so, I mean, I'd love to talk about more stuff, but I think I'm gonna stop there. Do you guys have any specific question on using the fuzzer to fuzz libraries and do differential fuzzing? Okay, we see as I leak my
So
DMs.
is this repo public?
The repo for the libraries is not public. It's private, but you can write this in 20 minutes, so you don't need me to open source it. You can do this yourself. Just go get Soledi, go get Soulmate, and just compare them. It's not rocket science. Any other question? I'm gonna give you a nice treat about something that happened to us. So, in case you're not familiar with Recon, we help you build and also run the invariant tests. So the free version, if you sign up for free, we just use your GitHub to prevent DDoS. But like, if you sign up on the free version, you're gonna have access to these buttons: the public repo and building your handlers. Basically, they allow you to scaffold this very quickly. So we even have Soledi here. So the way you will build that will be just to grab Soledi and then paste Soulmate yourself. But in terms of the Pro version, we have a Pro version that allows running fuzzers in the cloud. And so I just wanted to demonstrate basically my day-to-day, which I think is awesome. I just really love it. I just want to share that with you, kind of as the concluding segment of our presentation. And so the idea is that, let's say you wake up and you have a good idea, like you have a really cool idea for a possible exploit or for or you're thinking about a specific state. It could be that you need a formula to overflow, you need a certain value to happen, etc. And so what you will do is you will set the fuzzer. In this case, I got this compare libs private repo that I've already installed Recon in. And so I would basically write a couple of my tests and then perhaps go for breakfast, go for lunch, go do whatever, go do something else. And then you just run the fuzzer. And in this case with Medusa, that's literally all you gotta do. You just drop the Medusa.json setting in the root, and then you just paste the URL, and then you click run job, and that basically makes the run go. And I guess I'll show that in a moment. But basically now there's a cloud machine that is being provisioned that is going to allow that to work. And so, but what I wanted to show is an upgrade we did yesterday that made Echidna a lot faster. And so in our previous iteration, Echidna was insanely slow. And now instead we actually have a really fast runner. So what I want to show you is I got the compare libs library locally. This is running a Docker file that we shared. If you ever watched my workshop with Antonio on eBTC, that's the same Docker file. We basically just reuse it here. And so to run Echidna locally, this is the most common command you will do. And I'll just put like 2 million tests just to prove a point. So this is 2 million tests. I'm just gonna paste this command and I'm gonna have it start, right? It's gonna start locally, it's gonna do its thing. Then I'm gonna go on in the cloud and I'm gonna do the same thing. I got compare libs. I'm gonna copy this and switch to the Echidna version. And then I'm gonna have to set up the path to the tester. I'm gonna set up my config file name, the contract name, and lastly, the 2 million tests. And what's going to happen is obviously it's going to take a couple of minutes for the Echidna version to be spun up, as the Medusa version maybe is already running. And you can see it's running. And basically, it's going to take a minute or so. But what's going to happen is that because of the fact that we have 10 workers in the cloud machine compared to this Dockerized version that only has one, what's going to happen is that eventually the cloud version is actually going to catch up to the local version. As it gets stacked as queued, my nightmare scenario. Hopefully this is gonna get unqueued soon enough. Whereas you can see with the Medusa run that we queued a little bit earlier, it's already started and every minute is gonna send an update here. So obviously we're not gonna find anything because I already did this for 12 hours. So it's not gonna find anything, but at the same time, I just wanted to share the improvement. Hopefully this queues after a minute, I guess, because that's our heartbeat. So we'll end the workshop unless you guys have a couple questions. I'm happy to do Q&A, but basically we'll end on this shot of the local run versus the cloud run, and we'll do like a race between them. This is actually what I did is I clicked on the share button, so now the URL is actually public, so everybody can check the run as it's happening, and you can also see kind of the settings, etc., that I set up. So let's see if we can do like a side by side. Hopefully it's not too unfair because this one is literally stuck at queued, whereas this one is already at 60,000 runs. So let's see if the cloud catches up. So at this point, I bet that I messed something up because I feel like it shouldn't be queued for that long. And whenever it's queued for that long, it's typically because it doesn't have permissions to read. Although I don't see any specific mistake done here, so we'll have to go and check. Let's see. We're gonna give it a couple of minutes, otherwise this is basically where I put it all on the line. Ah, okay, so maybe we are breaking the budget, but that doesn't make sense. Well, I guess we'll remain stuck at the queued screen. I'm gonna do my attempt at saving it. If you guys want to ask a couple of questions as I steadily check our infrastructure backend logs, I'll go and see if we can get it unstuck. So I guess next week, actually, I'm gonna tease. Yeah, go ahead.
I am checking the infra we are using.
Yeah, we got
128
rate
cores, so
limited, so we need to
Mhm.
go and ask to get to raise the limit, which is fine. So definitely go and do that or ask Antonio. And yeah, I guess that was us pushing Recon to its limit and seeing where it breaks. Appreciate your viewership, guys. Hopefully next week we'll do a better demo. So what we're gonna do, I guess what I'm gonna tease for next week is next week we'll do a retrospective on the work we did with Centrifuge. Centrifuge is a RWA protocol. So we'll either talk about it a little bit, or maybe we'll actually organize a actual workshop with the CTO. So stay tuned because next week we'll talk about more practical stuff. I appreciate again you attending these office hours. Feel free to ask us a couple of questions. Otherwise, you have an amazing rest of your week, and I'll see you next Thursday. And hopefully next Thursday the demo will actually work. You have an amazing one.